Yeah. Also, I'm one of the kernel developers. I'm maintaining 2 subsystems for the Linux kernel, and I also have done some modifications to OFED myself. So I hope I'm qualified in some way to talk about this. Can I see the next slide? All right, so the financial industry has various different compartments that have different types of use and different requirements for the use of OFED or for general software. For example, there are banks, the investment and retail banks. The main issue there is fairness. You don't want one customer to be faster than another. So in that case, you want to have an operating system and a kernel that works very reliably and that doesn't have delays for one customer that the other doesn't experience. So in that case, you want to focus more on real-time, stuff like that. The stock exchanges are even more sensitive to that. They have very high incoming volume of orders and very high delivery rates in terms of quotes or market situation. That needs to work absolutely hiccup-free. And they also have the fairness issues. So and then the investment funds, which are also similar, but they are much more dedicated to a certain area. All of these are much more focused on reliability rather than on speed. Whereas the last one that I've used in algorithmic trading, that's where speed really counts. Whoever is there first usually wins the trade. And so in that area, now there are trade-offs to reliability and toward fairness. You don't care if you're fair, you want to be fast, you want to be there first. And the HFT areas, that's where the most competitive use of OFED occurs, and where also the most tuning occurs. Oh, I see. Ah, yes, oh, yeah, okay. Okay, so the exchanges, the banks recently have mostly gone to 10 gig. I think they have been using traditionally 1 gig networking, and I think the Chicago Computer Exchange is still on 1 gig. Most of the other exchanges are now trying to move into 10 gig, which is already a step down from the speeds that we have in InfiniBand. There is some use of InfiniBand with the exchanges. Core on they're using OFED. But the handovers occurs either as 1 gig or 10 gig Ethernet. They want to be standard based. And there are various progress now to maybe do an InfiniBand handoff. The problem there is that we can't really route 40 gig InfiniBand, or we can't route InfiniBand at all, unless Jason wants to succeeds with his book. And so, what is planned there is either a handoff point on a host bit, either on the customer's premises or on the exchange premises. Basically, 2 InfiniBand NICs, and then there's going to be some other software that does a handoff. The problem is always who gets this. If the exchange gets a handoff point, then the traders are going to be skeptical of what they're going to do with their traffic. And vice versa. I mean, if you do onto the customer side, then the exchange will want to have a guarantee that this is reliable. So there's a lot of policy issues on that. Exchanges and banks have mostly also more HPC usage style. So they have the same problems that high performance computing has, with having high throughput. They run simulations of market events, and they have huge computational farms where they will try to predict what's happening next in the market. And banks particularly have extremely complex algorithms that calculate valuations for various symbols and various products worldwide. And those get more and more sophisticated every day, and it takes more and more time to calculate that. Let's see if this works.
I have a question.
Yeah.
Why is real-time important?
It's a matter of fairness. If you don't have a real-time kernel, you can have some kind of OS action to delay your trade. The other one gets the trade and you don't. And at that point, something happened to you that was outside of your control. And at that point, the trader would say, the exchange, it was the exchange's fault. You delayed my trade, and the other guy won it, although I was there first.
No prize for second place.
Right. There's one lot of grain or something, wheat, that you can buy, and at that price, and he got it, and I didn't get it. That's a loss.
So the SEC is considering a certain rule about having to pay for the trades.
Yes.
Which segment of the business would this be?
Most of them, all engage in these kind of practices. The frequency of that varies. The specialists in that are most of the high-frequency traders, but the banks see, and the investment companies see that the HFT traders are successful, and they try to imitate that. But they don't have this dedication. Usually they are second-rate customers at that level, and they usually don't earn too much. So then we have the area of algorithmic trading. That's where the speed is the all important issue, and the reason to use Infiniban and OFED there is due to the very low latency. So that's a compelling case, and a lot of trading companies have gone into this area and have made use of OFED for that purpose. So also OFED allows kernel bypass. So kernel bypass is frequently used. Infiniban is one of them. There's other proprietary solutions like Solarflare that does 10 gig offload, and various other things like Chelsea also based partially on OFED, partially on other stuff, where you can also do offload without using OFED. And the reason, again, to use 10 gig is because Infiniban technology is extremely complex. It has been very difficult for various companies to master this technology. And I know of a lot of failed projects where a company, investment bank or so, tried to get into this, and they wasn't able to get code with the scale that they wanted to go to, and they had to either abandon the project or scale back because of the complexities involved. One thing that's widely always receives not enough treatment, as far as I can see, is that the financial industry requires extensive use and reliable use of multicast. Most people only think about networking in terms of unicast. The challenge in the financial industry is to distribute quotes about a certain valuation of a product in a scalable way. And usually this involves can involve 10,000 to 20,000 of systems. You can't do this by going one by one. It'll take forever. So what you do is you send a multicast packet where you have hardware support in the switches and routers that does the distribution of these packets and of the information to all systems. And that is that's mostly valid for market data. That's a strictly multicast. Actually, it comes from the exchange. The exchange finds there was a trade conducted, and there's a new valuation, and it sends out that information via multicast. Then it goes into all the various trading systems of the banks and of the others, and then it's replicated in these frameworks. And that has to occur as fast as possible, because evaluation may mean that you now need to sell or buy a product. And so this is a huge challenge for the hardware and software. And actually, we've been working with Mellanox and Voltaire extensively over the last 3 years to get this issue addressed. At the beginning, there were not even QA processes for that. And these days, at least with the current brand of products, we are pretty sure that this works in a more reliable way. So also, the typical thing is we've talked about the global routing infrastructure for Infiniban, I think it's for computing, and of course what was forgotten there was also multicast. So,
Could you explain what you mean by reliable? You say the reliable layer.
well, multicast traffic uses unreliable datagrams, right? Cannot use a connected mode. And therefore, many people who design their devices think, okay, this is unreliable, I can just toss the packet when I wish. And it's inconvenient for me. And we've had to work with these issues, given Mellanox think, and they had to fix their switches because they had these ideas. Same thing is true also for the operating system. I've done various fixes to the Linux network stack because the device driver writers and the network stack designers thought, oh, it's an unreliable packet, we can just toss it. So what usually happens in order to make multicast reliable is that the endpoint verifies that it got all packets. So the market data delivery from the exchange introduces a sequence number. This is the first quote, second quote, and so on. And so downstream, the consumer of this data verifies this sequence ID and figures out, oh, I have a gap now. And then I introduce a recovery protocol. This means now the endpoint is doing a unicast request to back to the exchange. I didn't get that data. And then it sends it down. So that works well if you use one or two packets. Let's say one of your switches goes on the fritz and the firmware writer or the designer of the ASIC just thought, okay, I can just toss this packet. Packet gets tossed at the top. Now there are 1,000 clients down there that are missing a packet. 1,000 requests go back to the exchange. The exchange will go down. You can't do this. So there is a key point here that we need to make sure that the unicast, the unreliable datagrams must be reliable, at least at the switch level. At the host level, we can tolerate that, but the higher you go, the more reliability is an issue.
How much is IPv6 used?
Not at all. Never heard it mentioned. Most networks are anonymous ASs, and they use private IP space, and they do some kind of NAT at the border. And since they do NAT, they feel that they're going to be safe with IP version 4 for the foreseeable future. On the other hand, some exchanges require you to have public IP addresses, and those run short. And it's not clear what to do about that. But I think they're going to be netting to some IPs that they already have, and they can forward before they do anything.
So how long is this market data? What's the time of life? The value of this market data decline exponentially? So if another trader got it, you are acting on it. Yeah. So you really need reliability. And what is the epoch that you actually care about?
Well, most companies also archive this stuff. They keep this for years because they want to do regression testing. Let's say they develop a new strategy. So they're going to run a simulation with the data for the next year and see, is this thing actually profitable, or should we just toss this code? So it has also even a shelf life. But for the immediate action, I would say, well, just 1 or 2 seconds. And that's already going to be wrong. Okay, then there's various messaging middleware that actually does make multicast reliable, and these are widely used in the financial industry. So 29 West is one of the classic ones that is widely used in New York. They recently also have started to provide Infiniban support because they saw the widespread adoption of Infiniban in the financial industry. Then there's TIBCO. TIBCO was mostly used in Chicago and that area. And it's one of the old things that came about in the 90s. And now they have a new product called FTL, faster than light. And so FTL is an Infiniban API, and it makes it makes all the latency significantly using Infiniban technology and also OFED based. Then there's IBM WebSphere. Usually don't go and think about low latency, but they have an LLM, a low latency messaging layer in there. That's widely used by the exchanges, and especially targeted to exchanges because it allows various fallback modes that the other solutions don't offer. So the Deutsche Börse, for example, Eurex uses LLM, and it seems that some other exchanges are also considering that. And IBM has put Infiniban support in there. It can run based on OFED and can give you very low latencies, and also has extensive recovery mechanisms so that if you're missing a message, you can do a retransmit without bringing it down the fabric. Then the NICE guys have brought out Mama. These are, they realized, okay, there are so many other products out there, we need a unified API. So they've developed a unified messaging API, and they put their own implementation on the bottom of this. The implementation is Infiniban based, the API is open sourced. and the Infiniban portion is proprietary. Yeah, so that's probably replaces 29 West in New York readily. And then we have Red Hat with AMQP, which is Red Hat's favorite messaging package. There have been various people that have pushed that. There's no special Infiniban support as far as I know. And to all of my knowledge, it's pretty dead in the water, but it's just being pushed. Everything runs on Infiniban if you run MPOIP, but does it do RDMA? I don't think so. Oh, it does. Okay, great. Look at this again. All right, so I already talked about the numbering of packets, and so the receiver has to ask for retransmission, and with that you have packet storm problems. You can just get your network overwhelmed with thousands of requests if the key component fails. There's even a standard that is how this recovery should work, which is IRC 3208. It's a PGM protocol. Pretty good multicasting. So in Infiniban Fabric, messaging has some other challenges. We have this idea of a lossless fabric. Now the receiver can slow down the sender. Let's say you have a multicast group with one sender and 1,000 receivers. Any one of those 1,000 receivers can now slow down the sender. So 1,000 people can yank the chain on this one sender. And this can be very problematic. If you have one slow guy in there, everybody gets slower market data. That's a big problem. So how do you deal with that? That has been kind of a headache for us over the years. There are ways to switch off the back pressure now. And recent analog switches, you can just say, okay, the leaf switches won't do back pressure anymore. But then you use packets, and then you have the retransmissions again. So, so the interesting thing is now, packet loss doesn't occur anymore in Infiniban Fabric. It occurs elsewhere. Let's say there's a slow receiver. He slows on the sender. The sender that's going into the fabric queues so much data that it can't queue anymore, and it starts dropping packets. Now you have a very bad situation. Now all the receivers ask for all the packets again at the drop at the very top. And then we have found there's another problem on exit. The NIC, analog NICs here, have no error message and no counter if a packet gets overruns the QP buffers. There's no QP buffer, just it's tossed. It's an unreliable packet after all, an unreliable datagram. So it's gone and you don't know anything about it. So there's a lot of issues in diagnosing these issues, this stuff, because you don't have any counters. So we've been trying to get that fixed, and it's still ongoing. So it would be good if we had some kind of solution to this issue. That we've thought, a lot of people about this, what to do about this. We like the losslessness of the fabric, but the back pressure must be somehow controllable. Let's say we could set a limit on the time. Let's say you can't slow it down more than 1 millisecond or so. But none of the approaches so far seem to have been workable.
Chris?
Yeah.
Doesn't, like, it's not even that doesn't DCE take care of this?
DCP?
DCE, right?
DCE.
The data center Ethernet, they got back in the pod, you can do individual target stuff. Seems like that works problem solved.
Yeah, but you can segment the space, yes. How do you segment the multicast groups that goes, everybody receives a certain symbol, let's say the E-minis get to everybody. How do you get to segment that?
So the sender there gets back pressure.
Yeah.
Sorry.
Well, then we have OFED, and we have this balance challenges with OFED. I think this shouldn't exist. What I want is this stuff should be in the standard kernel, and I don't want to constantly have to hunker around with patches and upstream patches against this OFED version, patches against that Red Hat kernel. So if you want to keep this around, please make it simple to do these steps. OFED has some kind of an artificial kernel release that they're based against. They rip out portions of the kernel and replace them, and then they patch it. And we can never figure out what that kernel version was and how to get to it. The scripts are cryptic, to say the least. It's very difficult to contribute and patch to. I'm a kernel developer. It's very easy for me to write a kernel patch, but when I get to OFED, my head stands up straight. It doesn't really have to be that way. Had to go through this pain several times because of important patches, but I think progress has been made to merge most of the stuff into the main kernel. I think Ron has been very good about that, but I think we've been pestering him now for a couple of months about some features that are missing there, and he doesn't respond, and we don't know what to do about this. I hope that he would be here, but I've heard that he doesn't show up at these meetings.
I don't think Roland likes OFED any more than you do. So.
But then you should put the stuff that we need upstream. Okay, good. So what we would like is some kind of an offload standardization. Infiniban is one thing, the API is another. So, and we figured out that Mellanox NICs can also do Ethernet. So now we are able to actually do Ethernet via the Infiniban Fabrics API. And so we wish to have that extended as much as possible so that all sorts of devices work that way. I think Cherso has made some strides in that to make that compatible with a 10 gig adapter. We've tried it and it failed. I was sure this is fixed now, so hopefully it works. But it would be great if everything on that level would work. Since QLogic was bought by Intel, hopefully the Intel guys also will design their future NICs in such a way that this IPVerbs API will work with their Ethernet adapters, and that we can have some kind of a way to have a single API for all these RDMA mechanisms. And maybe can generalize this API and clean it up a bit, because it's also very cryptic, and we have just a few mortals that understand in our company. And maybe we need to have some kind of a standard like POSIX. In POSIX we have this standard socket-based API for regular I/O. Could we have some kind of a standard in POSIX-like that describes the RDMA API that's standard for all operating systems and all devices will work with this? I've heard that something like that is going on various levels, but whatever I can do to support that, I will do.
So there was some work done several years ago on an API called Apple, which is in OpenFabrics, which was done to explicitly address that concern. It was an API that was developed that was by an organization, and the API was specified, and they defined it was implemented. It's not only it's OS agnostic and it's transport independent, right? So that's exactly what you're after. But the problem is not very many people actually adopt it. But I mean, there is something that tries to address that.
Okay. So now, another problem that we face now is, given that these transfer latencies are so low, as the latest Mellanox NICs go below 1 microsecond for transfer host to host, the OS events that occur are often much larger than that. So now we have a different challenge here, that any of our communication can be disrupted by an outright long event by the OS. So now we need other components to be merged into the kernel that reduce these issues. And there's, for example, an approach called the Gintix patch set, where we switch off the timer interrupt in the OS for CPUs that are dedicated to just running on a single CPU without any competitor there. This is in progress now, and I think for Linux 3.6 we hopefully have that merged. And then we can actually get rid of one of those major sources of latency, which is the time interrupt. And then the other issue is, in order for the exchanges to adopt this and the investment banks, there needs to be some work done on the real-time integration issue. The real-time kernel has a challenge that you cannot use the spin-locks anymore. You have to design your driver around mutexes and sleeping locks. So I'm not sure how well the OFED stack will work with that. As far as I know, the real-time stuff in the use cases of the exchanges using Infiniban is not being used. It's only, the read are only used outside of the Infiniban fabric, not within hosts that are connected there. Okay. That's it. Any questions?